In this lecture, we shall discuss functional dependencies. Firstly, we will see that we were discussing integrity constraints, and in integrity constraints we saw that we have got several schemes for specifying integrity constraints, namely domain constraints, referential integrity and functional dependencies. We have already seen what domain constraints are and how they are specified and checked. We have also seen the concept of a foreign key in referential integrity, and now we shall move on to functional dependencies. Functional dependencies is a very fundamental concept. It is a concept relating to the attributes of the relations in a database. In a database, you will recall that you first define all the attributes, and then the relation schemes, and then the relations which hold on that database. So when we define all the attributes, we now specify the primary keys of each and every relations. For example, we have specified in the book relation that accession number is the primary key. Here card number is the primary key. Here supplier name is the primary key. Here and here both accession number is the primary key. Functional dependencies generalizes this concept further. We shall see how it does so. Let us see how we could use the idea of a dependency to define the key relationship. Let us see the book relationship. We could say this: we denote a dependency like this. This means that whenever in any relation, not even corresponding to book, in any relation, wherever this holds, this means that year of publication is functionally dependent on accession number. The meaning is year of publication is functionally dependent on accession number. That means that there can be no tuples which have the same year of publication, which have the same accession number and different years of publication. That is, I cannot have two tuples which have the same year of publication and different values here. But I can have tuples, if I specify only this, I can have tuples which have got same values here, which have got same values here and different values here. If they have different values here, they cannot have same values here. So, if two tuples have same accession number, they must have same year of publication. And if they have different values here, they cannot have same value here. That is the meaning of this. And we have, in this particular case, since accession number is a primary key, we have also this relationship. which means that no two books which have the same accession number can have the different title. Therefore, when we define our super key or a primary key relationship, we may do so by writing it out in terms of such functional dependencies. And this is how we write it out. We write out the primary key relationship here. Let us come to the user relationship. In the user relationship, we have got this. Since card number is the primary key, so let us see. Let us list out how we will write down the primary keys in terms of functional dependencies. Accession number is year of publication. Accession number is title. From the user relationship, we get card number, borrower's name, and card number, borrower's address. From the supplier relationship, we get S name to S address. From the borrow relationship, we get accession number, card number. This comes from the constraint that a particular book can be issued by only one person. This was the constraint which came from the cardinality constraint in our ER diagram in the borrow relation, that a particular book can be issued by only one person. That is how we really had this. Otherwise, if we allowed a book to be shared issued by two people, then accession number alone could not have been the primary key here. We also had accession number to date of issue, and we had accession number to supplier name from the accession number to price and accession number to date of supply. So, based on our primary key concept, these are the checks which will have to be done during every insertion and updation and deletion as well. That is, these are based on concept of key attribute. So, based on the idea of a key attribute, we can specify what are called functional dependencies. But that is not all. Functional dependencies can be used to a further extent. Let us see. We have seen the concept of a candidate key. We saw that there may be more than one candidate key in a particular relation. So, if we have a candidate key, what does it mean? For example, let us see this. If we allow a person to issue only one book, then accession number is a primary key or a candidate key, card number is also a candidate key here. Now, the database designer may have chosen accession number, but the constraint that only one book can be issued will have to be specified. And what is that constraint? That if the card number is same, the accession number must be same. If the card number is same, the date of issue must be same. So, if we specify that, and we have already specified one primary key, how do we specify the others? So, if we use our old idea here, we can see that functional dependencies allows us to easily express those as well. we will simply write down this is based on primary key. This concept, these two we have introduced, these constraints we have introduced to say that whenever we have got card number to be same in any particular relation, then the two tuples must have same accession number. If two tuples have got the same card number, they must have the same date of issue. So, not only based on the concept of primary key, based on the concept of a candidate key, we may have certain things. Now let us come to another constraint. I will put in an artificial constraint to explain the meaning. We will come to more real examples later on. Since this is a simple situation, we are describing it by such a simple thing. Let us say that one particular supplier is allowed to supply only one book per day. That is the constraint. One particular supplier is allowed to supply only one book per day. Suppose that is the constraint. Now, what can we have? Whenever S name must be same, two attributes which, since we say that a particular supplier can supply only one book per day, how will we specify this? Can we specify it like this? S name this will mean that whenever S name is same, date of supply must be same. That is not the constraint. The next question is accession number. Anyway, accession number implies S name. Is this the case? This will mean what? The library purchases only one book per day. This means
combination of loss and S name will have
let us see what this means. Let us see what this means. I will write it out carefully. What does this mean?
one supplier has its supply of books of the same price on the same day.
we have not got our answer. What we have got here by this is that a supplier can supply only one book at a particular price on the same day. But the point is, using this idea of a functional dependency, we can have things which are not based, which we can have constraints which are not necessarily based on the concept of a primary key, and constraints which are not based even on a candidate key, because neither is date of supply nor supplier name a candidate key or any other key of the whole relation. It just means something else. So, if we specify a set of functional dependencies, then we can specify a set of added constraints which can quickly be checked during insertion, deletion and updation. During insertion, we have to check for duplicate elements do not exist, that is all. During deletion, no check is required, and during updation, the check corresponding to insertion is required. So, given a database, we can specify the primary, the candidate keys and a whole lot of other constraints in the form of functional dependencies. So, this is the idea of a functional dependency. Given the set of attributes, we just write down the functional dependency. For example, let us take another one. This would give us a candidate key in user. Card number gives borrower's name, card numbers gives borrower's address from primary key. I have now written down borrower's name and borrower's address. This side is AND, borrower's name and borrower's address gives card number. So, two tuples which have got the same borrower's name and address gives card number. Let us take another one. Suppose I give down borrower's name gives borrower's address, and I have my old dependency as card number gives borrower's name and card number also gives borrower's address. This is from the primary key, but borrowers, what does these three things mean in the user relationship, which is user, card number, this means that card number becomes the primary key because all other elements are dependent on it. However, borrower's name, if it is same, borrower's address must be same, in the sense that we cannot have two people with the same name and different address. Now, there are a lot of interesting features here. Let us argue this way. If card number implies borrower's name and borrower's name implies borrower's address, then effectively these two will imply this, because if you have the same card number, you must have same borrower's name, and if you have same borrower's name, you must have same borrower's address. Therefore, effectively, if you have same card number, you have same borrower's address. So, this relation is true if only these two are written. So, functional dependencies are such that they have got a number of interesting properties. They can specify primary keys, candidate keys, and can specify relationships between attributes which are not even primary keys, like here. and all of them need not be listed out. A set of functional dependencies will imply many other functional dependencies as well, and therefore there is a whole theory behind what are functional dependencies, what each one of them implies, what do they mean, how do we utilize this power of functional dependencies in a database design. These functional dependencies have other far-reaching implications which we shall discuss when we come to the issue of design of a database. So, having this informal introduction, we will now see what is the definition and some other formal properties of a functional dependency. Alpha and beta are two attribute sets. This is a set of attributes, this is another set of attributes. We say that the functional dependency alpha to beta holds on a relation R if obviously alpha and beta are subset of the set of attributes of R. If alpha and beta are not subset of the set of attributes of R, this functional dependency has no implication in this relation R. It has an implication in somewhere else. What does it mean? In any legal instance of R, this must hold. Every legal instance of R must have, for all tuples T1 and T2 in R, if their alpha part is equal, their beta part must also be equal. If their alpha part is different, implication says anything can happen here, they may be same or equal, I do not care. But if these two are equal, this must be equal, which also means that if these two are unequal, this must be unequal. It is the same meaning. If these two are equal, this must be equal, is the same as if these two are unequal, this must be unequal. So, this is the definition of what a functional dependency is. We will see some quick examples. Let us see two examples in an airline database. These are the set of flights: flight number, city of arrival, city of departure, type of plane. These are the number of seats free. This is not the seats free. Let us say this is number of seats free, that is flight number, date, this is the number of seats available. If this is the number of seats available, then we have the following functional dependencies. Flight number is a key attribute here. So, flight number gives date of arrival, flight number gives city of departure, city of arrival, city of departure, as well as type of plane, because it is a key attribute here. All flights which have got the same number will have the type of plane, city of arrival and departure to be same. But since they can fly on different dates, flight number will not be key attribute here. A same flight may be holding on different dates, we assume that. And if flights are daily, that is there is only one flight per day, then flight number, date will give you uniquely the number of seats available. On the other hand, if we start having flight numbers, same flight number on the same day we have got that same flight number twice, then this will not hold. But normally that is never the case. On a particular day, the flight number, on a particular date, the seats available, this is the number of seats available. So, we have this functional dependency. On the other hand, if this is the seat number, that is not the number of seats, it gives you which seat is available, then this relationship will not hold. Then this relationship will not hold. For example, this says flight number C119 on date 12/3/37, seat number 35 is available. You will also have such C119 on that date, seat number 36 is available. So, if seats free, it is dependent on what seats free defines. If seats free defines the number of seats available, then this is fine. If seats free defines which is the seat which is available, then this is not the functional dependency which has to be put in. Let us see student grade relationship. Here student address, name and address. If name is a key attribute, then name gives address. It may be such that name is not a key attribute, then this relationship will not hold. Then this both of them together form the primary key. There is no subset which is the primary key. Student grade, if name and subject uniquely give the grade for this particular name, this subject, the grade is there. This is the meaning of this functional dependency. Let us see a simple bank example. Branch name, accession number, customer name, balance. The customer relation, this is the deposit relation. The customer relation is customer name, street, city. The borrower relation is branch name, loan number, customer name, amount. And the branch relation is branch name, assets, and branch city. In the deposit, if account number is the primary key, then account number will have account number to branch name, account number to customer name, and account number to balance. Maybe name and city, name and street implies the city. Here loan number may be the primary key. So here we may have, this is the primary key. Here these two together is the primary key. Here this is the primary key. And here this is the primary key. So based on primary keys, we will have a set of functional dependencies. We may also have, if we say that a person can take only one loan from a particular branch, then we will have branch name and customer name will imply loan number. That is, we will have, I am not writing out the key attributes, branch name and customer name will give loan number. And since loan number is a primary key, automatically branch name and customer name will also imply amount. So we can put in a number of such examples here. Finally, let us see a table. This is a table, a relation with attributes x, y, z and w, and these are the instances on the table. In first tuple is x1, y1, z1, w1, second tuple is x1, y2, z1, w2, third tuple is x2, y2, z2, w2, fourth is x2, y3, z2, w3, and the fifth is x3, y3, z2 and w4. The question is, which functional dependencies hold here? Let us see them one by one. Does x to y hold? It does not hold, because when x is same, y is not same. So this does not hold. X to z holds? When these two are same, these two are same. When these two are same, these two are same. So that's fine. Whenever they are same, so in this holds. Does x to w hold? When these two are same, these two are not same. Y to x holds? Y to x does not hold. Y to z? Y to z does not hold. C tuple 2 and 3? Y to z does not hold. Y to W, there is only one case here, it holds here but it does not hold here. So Y to W does not hold. Z to X, it holds here, it holds here but it does not hold here. Look at this, a Z to X to X3. So Z to X also does not hold. Z to Y, it does not hold. You look at this. And Z to W obviously does not hold. W to X does not hold. W to Y, W to X does not hold. W to Y holds. And W to Z does not hold. So we've got, when we look at single elements, we've got only two which hold. But when we look at them together, do we get anything else? Does X and Y give anything? We can always say X and Y give Z, because that is not violated. We can always say X and Y give Z, this is not violated, because there are no tuples with the same value of X and Y. So we will say this holds. Similarly, but we cannot say Y and Z holds. YZ gives X. There is nothing here which violates XY gives Z. But let us see YZ gives X. Here we have got two tuples which are same and different in X. So this does not hold. So a functional dependency does not hold only if it is violated. Otherwise, by default it is true. That is the definition here. If these two are equal, this must be equal. If these two are not equal, I don't care. So similarly, you can list out all the functional dependencies here and test them and find out which holds. But this is not the way we look at it. In a database, we first define the attributes and then we define the functional dependencies and we check them during the insertion, deletion and updation operations. We will stop here and we will see in details functional dependency in the next class.